But the first one, the property of closure, means the following. If you have numbers from the same set or subset, and they yield values that still remain in that subset, it's the property of closure is applied. Okay, so what this means is closure is true for real numbers. For addition, right? If you add two real numbers, does the value result in a real number? If you take any two real numbers and you add them together, is the result guaranteed to be a real number? Yeah, so that's the property of closure. It stays within that subset. And so adding two real numbers works. And what about subtracting? If you subtract one real number from another real number, will the result be a real number? Yeah, so subtracting is adding the opposite, so subtracting works as well. What about multiplying? If you multiply a real number times another real number, will the result always be real number? A value that can be placed on a number line? Yeah. So addition or multiplication works as well. Okay, what about division? If you divide any real number by any other real number, do you always get a real number solution? No, because you could divide by 0, right? Okay, so if you divide by 0, that doesn't work. So division does not fit within the property of closure for real numbers. And so this property could exist for independent things, so like integers. If you add an integer to an integer, will the result be an integer? Yeah, so for the subset of integers, addition maintains that property of closure. But what about division? Division does not work for integers as well. So this works for, again, any type of subset you might see that property. Okay. Now we move to the next set of properties. Again, these are ones that you've probably seen before. Okay, the commutative property. What commutative property basically states is that the order is going to change. Okay, so the biggest thing about commutative property is that the order will change. Okay, so if we take a look at this kind of illustration. So if your original relationship is A plus B, what the commutative property of addition states is you can reorder those terms without changing its overall value. Okay, the sum of two numbers remains the same despite whichever one comes first. Okay, even if we have multiple groups or multiple terms, so we have a binomial grouped together, so x plus y, that whole quantity plus z, that's equivalent to z plus the quantity x plus y. This is still an example of commutative property. We took the order of our terms, we switched them around, however, the total sum is not going to change or be affected. And the same property holds true for multiplication. If we take a property, A times B, it doesn't matter which order we multiply it, it's the same as taking B times A. And even if we, again, group it, if we take the quantity x, y, and we multiply that product times z, we can change the order here, and that's equivalent to z times the quantity xy. We reordered our factors in this case, but the overall product remains the same, is an example of commutative property. Okay, you guys have seen this before, yes? A little bit. All right. The other property that's sometimes confused with the commutative property is the one in which the order does not change, only the grouping changes, and that's called the associative property. So in the associative property, again, the key element is there is no order change. Okay, so an associative property relationship will take a group. So again, it would be similar to what we had before. We have this group of terms, A plus B, and that quantity is being added to C. If we keep the order the same, but we regroup it, okay, so here it's still A, B, and then C, but the grouping has changed. So that's the associative property. Okay, this same property holds true for multiplication. if you take the product AB and then you multiply by C, that whole total product is going to be the same if we take A and then multiply it by the product of B times C. And now, the associative property is something that you most likely just kind of intuitively do. And so if I gave you something simply 17 times 5 all times 2, what's that overall product? Yeah, you can do it very quickly in your head if you regroup by associative property, right? So what if we regroup this and instead of putting the parentheses in the front, we put it in the back? What's 5 times 2? 10, 10 times 17, 170. So it allows you, the associative property kind of allows you to work quickly through mental calculations. All right, the one last property or algebra rule that you should be familiar with is the distributive property. Oops, I'm sorry, we'll get to that here in a second. I guess there's some identity properties to look at. Hey, when you're looking at the identity properties, and the gist of the identity properties is the value stays the same. Okay, so when you're looking at this, when you're adding two things, what can you add to a number so that its value stays the same? 0. So that's identity property of addition. And for multiplication, what can you multiply a number by so that its value stays the same? 1. And so that's real simply what those properties are illustrated by. Okay, and then the last one is what we talked about earlier with the number lines, the inverse. Okay, the additive inverse and the multiplicative inverse. Remember, the additive inverse is the opposite. Okay, and so the property is if you add a number and its opposite, what's the total sum going to be? 0. So a number and its opposite, they're equal distances away from the origin on a number line. So if you combine them, you get back to that 0, that origin. And then the inverse property of multiplication, remember we're looking at the reciprocal here. And so a multiplication, if I took A and I multiplied it by its reciprocal, it's going to have a value of 1. And again, assuming that A wasn't 0, where it would be an undefined value, that inverse property will hold true. All right, so now the final one is one that you are probably more familiar with as well, and that's the distributive property. Okay, the distributive property works in two ways. It works to expand, and it works to factor. And so you can apply this in either direction. When you're expanding, the distributive property looks like this. If you have a factor times a sum or difference of terms, you can use distributive property to what we call distribute that first factor through. It becomes the sum of the products of AB and AC. We distribute this lead factor to each of the terms inside the grouping symbols. Okay, so that is the distributive property. We can also use it to go in the reverse direction. Okay, if we have an expanded expression and we notice that there is a common multiple in each term of your expression, you can factor that out using the distributive property. So here, each of these terms has a common factor of x. When we take it out, we're left with a y plus a z. And so that's an example of the distributive property.